Hey folks, in today's video we're going to be talking about rotations of figures, and rotations are exactly what they sound like. It's when you take a figure on a coordinate grid and you rotate it around a central point so the figure spins. The figure will not change size, the figure will not change shape, it will simply spin around a central point. So let's take a look at what that means. So a figure will be rotated around a center. The shape and the size don't change, just the orientation. And the figure, in my classroom, we will always rotate counterclockwise, which of course is in this direction. Figures can be rotated clockwise as well, but just for consistency with the students I work with, we're going to be working on counterclockwise. So let's take a look at some examples. So if this figure right here is our original, which is a nice weird looking shape, this shows a 90-degree rotation, all right, because what we did is this thing spun clockwise about 90 degrees. So let's say like this is the center point where I'm holding the red dot. That's the center point. So the figure spun counterclockwise 90 degrees. So every point on the figure rotated like this, about a quarter of a circle until it stopped here. Okay? So that's a 90-degree rotation. This is a 180-degree rotation. So once again, if we're back at the original figure, we're spinning counterclockwise. Every point on my figure has turned about a half circle. So like this point here has spun about a half circle, and it has now ended up right about here. All right. And finally, this shows a 270-degree rotation. So, once again, every point on this original figure has spun about 3/4 of a circle. All right. All right. So here we have some figures in the rotation. So the shaded figure is our original, and the non-shaded figure is our rotation. So about how many degrees has the figure been rotated? So what I like to do is just compare corresponding points on the two figures. So take these two triangles right here, and we'll use this point right here on our original. Okay, so, and we're spinning counterclockwise. So starting at this point, if we spin about that much, that's a quarter circle, so that's 90 degrees. So we keep going and we spin about this much, half circle, that's 180, that's where that would end up. So if we keep going until we get to the corresponding point, it has spun, that's 3/4 of a circle, that's 270 degrees. So that's a 270-degree rotation. All right, this trapezoid. Let's compare this corner right here on our original, and the corresponding point on the rotation is right here. So let's trace our circle starting from here to about right there. That's about a 90-degree rotation right there. Continuing along till you get right there. You see how that forms about a half a circle? So that is 180 degrees. All right, here we have a pair of arrows. So we're going to trace this corner to this corner down here and see how far that's rotated. So going from this point down to that point, that's about 1/4 of a circle spin. So that is a 90-degree rotation. Okay? Moving on. So suppose you have a figure on a grid and you know its coordinate points, and you need to rotate that figure a certain amount of degrees. There are rules that you can follow in order to do that. So all points on a grid, remember, all points are always x, y. All points are always x, y. So here are our rotation rules. If you want to rotate a figure 90 degrees, you will flip the x and the y so that now the y comes first, and also the y will become its opposite. So that's what this negative sign means here. Not that the number will definitely be a negative number, but that the number will become its opposite. So if your original y was a positive number, then yeah, it'll be a negative number. But if your original y was negative already, then it'll become positive. That can sometimes be confusing. But the more you practice it, the better you'll get at it. But anyway, that's what you would do for a 90-degree rotation. Flip-flop your x and y, and the y will become its opposite. For a 180-degree rotation, your x and your y will stay where they were to begin with, but both x and y will become their opposite. For a 270-degree rotation, your x and your y will flip-flop again, but your x now will become its opposite. All right, so we're going to practice these rules. Okay, given the point 3, 4, what points will you have after a 90-degree rotation, a 180-degree rotation, and a 270-degree rotation? So we're going to apply our rules. So for a 90-degree rotation, the first thing we do is we flip our x and our y. So if it was originally 3, 4, now it's going to be 4, 3. And our y has to become its opposite. So our y was originally a positive 4. It is now going to be a negative 4. So our new point is negative 4, 3. All right, for a 180-degree rotation, the x and the y stay where they were to begin with. So our point is still in the order of 3, 4. But both numbers become their opposites. So this will become negative 3, negative 4. Finally, for a 270-degree rotation, our x and our y flip-flop, just like they did for a 90-degree rotation. So the order will be 4, 3. But now our x will become its opposite. So our original x was a positive 3. Our new x will be a negative 3. So now our point is 4, negative 3. All right, and you would still plot those according to x and y, though. So even though you flip-flopped here your x and your y, you're still going to move to the left 4 spaces first and then up 3 spaces for this point. All right. Using 0, 0 as a center point, rotate the figure below 90 degrees, 180 degrees, and 270 degrees. All right, so the first thing we're going to need is our points, the original points for this. This is our original figure. You're not going to be able to do this without original points. So I'm going to write my original points up here. So my original points, and I'll just put a star. Our original points are 1, 0, 4, 0, and 1, 2. All right, so let's do a 90-degree rotation first. All right, remember the rule for a 90-degree rotation is you flip-flop your x and y, and your y becomes negative. All right, so for this first point, we'll flip-flop our x and y. We get 0, 1. Now, 0 cannot be negative or positive. It's not counted as negative or positive, so there's no way to have a negative 0. This next point, the same thing is going to happen. When we flip-flop our x and our y, again, we can't have a negative 0. All right, but with this point, when we flip-flop our x and our y can now become 0. All right, so here's the new points for a 90-degree rotation. So let's plot those points. So 0 and 1 will go right here. 0 and 4 will go right here. And negative 2 and 1 will go right there. So you plot, and you connect your dots, and you can see that our figure has now spun 90 degrees. All right, let's do a 270-degree rotation. No, let's do a 180-degree rotation first. All right, so for a 180-degree rotation, our x and our y stay in the same spot as the original. We're going back to the original points here, but now everything becomes its opposite. So our first point will be -1, 0, -4, 0, and -1, -2. All right, so let's plot those points. So -1, 0 will be right there. -4, 0 will be right there. And -1, -2 will be right there. Okay, connect your dots, and there's our figure after a 180-degree rotation. Finally, let's do a 270. All right, so for a 270, our points flip-flop. Now our x becomes negative. So our first point is going to be 0, -1. Our second point will be 0, -4. And our third point will be 2, -1. All right, so let's plot those. 0, -1 right here. 0, -4 right here. 2, -1 right there. Plot our points. Whoops. And there it is. All right, so that's it for rotations. I hope that this all makes sense and use it in good health. Thank you.